Sorry, ma'am. Because
No,
many times it happens.
yeah, can
Thank you, ma'am.
understand. No problem.
Okay, start reading better. Yes, boys, what happened?
Yes,
Yes, start reading better.
yes. Speed of sound. The rate at which sound travels in a given a medium is called speed of sound. First, the speed of sound depends on the nature of material or medium through which, it travels.
Good.
In general, sound travels slowest in gases, faster in liquid, and fastest in solid. Speed of sound in air is 344 meters
Second,
second at room temperature 20 Celsius. Speed of sound in water is 1500 meters second. Speed of sound is iron is
5,130.
5030 meters second.
Okay,
One,
fine. So now what is speed of sound? Simple is the rate at which sound travels in any medium, whether it is gas, liquid, or solid. That is called speed of sound. How does it depend on the nature of material? We'll see. It always depends on the nature of material through which it travels. Let's see what is the speed of sound in different material. And the observation is that it's slowest in gases, faster in liquids, and faster in solid. That means it moves the fastest in solid, a bit slow in liquid, and the slowest in gases. The analysis that they have made is that in air, the sound speed is 344 meter per second, the least, right? You can say it is only 344. It is in hundreds. Whereas in liquid, that is water, it is in 1500. And see in iron, that is solid, it is 5130. And imagine how it is increasing. So it is in hundreds, it is in 1500, and this is in 5100. So gradually, uh, it is the lowest in air, that is gas, and the maximum in iron, that is solid, is almost 5130. So the analysis is from this point we can make out that first of all sound needs a medium. That's the first thing, this confirmation that sound needs a medium through which it can travel. Okay, it needs a medium. If it does not have any medium, we cannot hear any sound. And secondly, sound travels the fastest in solid, then liquid, and then gases. Hope you have understood from this analysis.
yes.
Now we'll come to the second point. Yes, Vita.
The speed of the sound depends on temperature of the medium. Speed of sound in air at the 0 Celsius in 332 meters second
Per
and
second. Vita,
per
it is per
second
second.
per
Yes.
second. At 20 Celsius it is 344 meter second
Per second.
per
See, this is
second.
oblique. This is oblique, isn't it? Can you see this oblique?
Yes,
If this is oblique, that means it is per second, correct?
second. Yes. The speed of sound depends on the humidity of air.
Humidity.
Humidity of air. Speed of sound in dry air is less but more humid
Yeah.
air.
Okay, thank you. So the second point says that the temperature also comes into account. If this air is at 0 degrees Celsius, very pretty cold, then the speed of sound is less. As you increase the temperature, the speed of sound becomes more. So what is the analysis over here? That as you reduce the temperature, the speed of sound becomes less. And as you increase the temperature, the speed increases. So it is directly proportional to each other. Got my point?
Yes.
So more the temperature, the speed will be more. The less the temperature, speed will be less. So you can see over here is 332 and this is 344. So obviously there's an increase in the speed. The third and the last point is that it also depends on the humidity of air. What is the humidity, beta? In other words, we can call it as moisture. The moisture or the water vapor which is present in the air or the atmosphere is called as humidity. So what they say is that if it is dry air, that means if the atmosphere does not have any humidity or any moisture, the speed of sound is less. But if there is moisture in atmosphere, then automatically the speed of sound increases. So humidity increases the speed of sound. Is it clear?
Yes.
Okay, fine. All of you understood better?
Yes.
Boys? Yes? Only one, two
Yes.
yeses I'm getting. So it's just a data, speed of sound in different media.
Yes.
So first we started with gases. You can see it's in 300 gases. Then it comes to liquid. Till here it is gases. See, till hydrogen it is gases. So hydrogen has got 1000 almost. After that, this is gas. Then we start liquid, right? So water is distilled. You get 1498. Then seawater, blood. Till here it is liquid. You can see this. So 1004 to 1005. This is what we got. And now we start with solid. Till blood it was liquid and now it is solid. Can you see the difference? It is increasing.
Yes.
See? It is increasing. All of you understood better? Hello?
Yes.
Yes? Okay. It's the same thing, but again in a different format. What is speed of wave? What is the sound? Because sound travels in waves, we know that. So what is the relation between speed? Speed is equal to wavelength upon time period or lambda frequency. So you can see over here it is wavelength upon what is wavelength beta? Lambda. And what is time period? T. So it is equal to lambda upon T. And we know that 1 upon T is frequency. We know that, isn't it beta? What
Yes.
is frequency? 1 upon T. So I can write this as lambda into 1 upon T. Can I write this?
Yes.
Yes. So instead of 1 upon T, what I have written? Frequency. Any problem?
No.
So you got this formula. Let's do the revision again. Just sort of refreshing whatever we learned yesterday. Start better. If anyone else wants to read, can take up. I think it's Salman, right? Salman, is that
Yeah.
you? Okay, fine, good. You are doing very well, beta. Okay, can anyone else? Kadir, Abdul Kadir, Akbar, anyone? One by one, I need a change, please.
Yes, yes.
Yeah, start reading, beta.
Wavelength is the distance from the center of one comparison to the center of the next comparison.
Slowly,
Time
slowly.
period.
Don't rush, please. What is wavelength? It is the distance between, you see this? This is one compression.
Yes,
This is
from the
one
center of
compression.
one comparison to
This
the
is
other
second
comparison.
compression. Yes. So this is the distance between one compression and the that is consecutive compression or consecutive rarefaction. So that becomes wavelength. All of you agree, beta?
Yes.
Yes, ma'am.
So that is lambda. So it's center of one compression to the center of next compression. Now what is center of one compression? It is C, right? So this is the center of one compression. What do you say? This one and this one, right? This is lambda. What do you say? So this is the center, isn't it? This is the center. This one is the center. What do you say?
Yes.
Okay. Now we'll come to time period. What is time period, beta?
Time period is the time it taken for one full wavelength
Takes
to pass a certain
takes
point.
it takes one full wavelength to pass a certain point. So what is one full wavelength? As I just taught you, from one compression to other compression, from one rarefaction to other rarefaction. That is one complete wavelength. Is it clear? How much time does it take? That will become time period. Any problem?
No.
Now what is the frequency?
Frequency F is waves per second.
You understood? In 1 second, how many waves are traveling? That is frequency. Hope you have understood. So what is the formula?
F is
Frequency
equal
is equal to 1 upon
to time.
T. Yeah. Time period. You understood now? That is the relation between frequency or the, uh, what do you call that as? Yes, the relation between frequency and the time period. You can put T over here also. You can write this as well. T is equal to 1 upon frequency. What do you say? So they're inversely related. What are they, beta? They're not directly proportional, but they are inversely proportional. Yes or no?
Yes.
Yes, ma'am.
Now we'll come to wave speed.
Wave speed S, the distance covered by a complete wave in a given time.
So you understood how much distance it is covering at a particular time. That becomes the speed of the sound, that is wave. Because we know the sound travels in waves, isn't it? Yes?
Yes.
Yes? Okay. Now we will compare because we know the sound travels in waves, light also travels in waves, isn't it? We know that. Now we are going to compare the speed of sound and the speed of light. Let's begin with a
Comparison of speed of sound and light. Sound travels in air at 20 Celsius at the speed of 344 meter per second. Light travels at the speed of
3 into 10 raised to power 8 meter per
10
second.
raised to
10 raised to power 8.
10 raised to power 8 meter per second.
Yes.
Example: in the rainy season, the flash of lightning is seen first and the sound of thunder is heard a little later, though both are
So they,
produced at the same time.
you know that, right? You know
Yes.
that, isn't it? Okay. Second,
In the game of cricket, the ball is seen to hit the bat first and the sound of hitting is heard a little later.
Oh, heard. It is heard. Then,
If a gun is fired from a distance, we see the flash of gun first and the sound of gun shoot is heard.
short. Short.
Of shot is
Short
heard
is heard. A
a little.
little later. Okay.
In
Then,
village, when clothes are washed by beating them on the stone, the cloth hitting the stone is seen first and the sound of hitting is heard a little later.
so all these are examples just to show the comparison of speed, okay, of the activity and the sound. That's it. So we can see the activity first, and the sound is heard later in all the examples. You agree? Yes? All of you agree or not? Only one is agreeing.
Yes,
So you have to interact. If you interact more, you will learn more better. Don't be passive. I need active class. Ask whatever comes in your mind. See, you cannot keep your mind just, like sleepy. It has to work. And it can only work when you're into the session. You have to be active in the session. Then only your brain will work. You should feel like asking this or that. That's all. So you're making your brain work. You have to do better. Whatever I can do, I am doing it. The rest is all in your hand. How to make use of it. You understand?
Yes.
So what we observe here, beta, that sound is traveling in air at a normal temperature is 20 Celsius. The speed is 344 meter per second. That is sound travel. Whereas the light is traveling, how fast? 3 into 10 raised to power 8 meter per second. Can you see the difference? This is 344 meter per second. And this is 3 into 10 raised to power 8. It's a huge difference. Can you observe that better?
Yes.
Yes. And this is exemplified by all the examples that you read out. For example, let's take the first example. In the rainy season, you can see lightning first and then it is followed by the thunder. You all of you agree with me? First you see the light falling from the sky and then slowly the thunder will roll. You will see the thundering sound later. Yes or no?
Yes.
yes, ma'am.
Similarly, in the game of cricket, what we see first, that the bat hits the ball, and then you hear the people or the batsman or the fielders who are obviously we won't be able to hear it, but the people who is hitting, the batsman who is hitting, and the fielders who are around him can hear the thud of the ball hitting the bat later. Do you understand? The
Yes.
activity is done first. He hits the ball, no doubt about it. So we see that activity first. But the sound of ball hitting the bat will be heard a bit later. Similarly, if you see a rifle or a gun shooting, you can see the flash of uh, gun first, you can see the light first, the spark first, and then later we can hear the gunshot. Similarly, in villages, when people usually go to river banks to wash their clothes, first we see the activity that they are beating the clothes. But the beating activity is seen first, and later we can hear the sound of the beating. You understand? The
Yes.
activity is first, but hearing the sound of beating is later. Do you understand? Both are not together. What I say? Both are not together. It is simultaneous. You understand? A bit later, we hear the sound always. Any problem so far?
No.
No.
Yes? Abrar? Hello?
Yes, ma'am.
Yes? Any problem, beta?
No.
Take part, beta. Take part. You should say, ma'am, I wish to read. Ma'am, I wish to ask you this question. I'm not able to follow you. Could you please explain again? Why not, beta? So, Abrar, that means you're giving me out this time. No excuses then. If you're not asking me any question, that means you're thorough. You know everything. Is it so, beta? Abrar, I'm asking you. Hello?
Yes.
Yes. Hope you understood what I'm asking you. What I want you to be perfect, beta. If I'm saying you can be, for sure you will be. But that for that reason, I need your help. And the help is only that you have to be true to yourself. If you have any doubt, stop me right away. That's
Okay,
all I
ma'am.
want. No, that's all I want. I
Okay.
don't want anything else. Okay? Fine.
Okay, ma'am.
Okay. Rest of the class, any problem regarding the slide, beta?
No, ma'am.
So what we have understood from the slide? That sound.
Light is faster than sound.
Exactly. Very good. That's only summary. So I'm happy. This is what you have to do now. You have to keep me on the side. Now you have to take the charge, beta, all of you. So what
Ma'am,
is in totality? Yes, beta?
I want to read.
Who is it?
I want to read.
Yes, who is it? What's your name?
Kala
Smile.
Ismail.
Kalvesman. Thank you, beta. Okay, next slide you take on. Okay?
Okay.
Okay. Did you understand Ismail? Did you
Yes.
understand this slide? Okay,
Yes.
fine. So the summary of this slide was that
Light is
light
faster than sound.
faster than the sound. Very good. Now we are going to talk about a total new topic. Total new topic, that is reflection of sound. Remember we had done reflection of light? Do you
Yes.
remember? Yes? Fine. So we are again going to do the reflection of sound. Yes, please begin with it.
Reflection of sound. Like light, sound get reflected
There
at
is a
the
comma.
surface of a solid or liquid and follows the law
Smile,
of reflection.
smile,
Hello.
please stop. Yeah, who is it?
अब्दुल कादिर रीड कर रहा था मैम मैं नहीं.
Okay. Abdul Qadir, Ismail has to read better, if you don't
यस
mind.
मैम, वो रीड नहीं कर रहा था तो मैंने कहा मैं रीड कर दूं. वो रीड ना
Okay,
कर.
okay,
मुझे आवाज
okay. He will continue. Okay,
ओके.
and Abdul Qadir, there's one thing I want to just relate. That wherever there is a comma, you have to pause better. Okay, don't read everything together. Wherever there is a comma, please stop for a while. Okay, because it is used for the meaning. Otherwise, the meaning will be lost. Okay, better.
Okay, ma'am.
Thank you. Okay, Ismail, start.
Okay. Like light, sound get reflected at the surface of solid or liquid and follows the laws of reflection. First, the angle of incidence is equal to the angle of reflection. Second, the incident ray, reflected ray, and normal at the point of incidence all lie in the same plane.
Okay, so what is the reflection of light? What is the reflection of light, beta? I just want to show you. Now, this is the surface, right?
Yes.
Which is this light, beta? Which is this light? Incident light. Say,
Incident.
incident light falls, and then this is reflected light. Agree?
ये तो
Yes.
Hello?
नया सेम.
Hello? Do you agree?
Yes.
Then what we make? What we make? We make a normal. Yes or no, beta? We make a
Yes.
normal. That is 90 degree. Remember? It's 90 degree. Remember? Fine. So incident ray and the normal makes which angle better? Angle I. Normal and the reflected ray makes which angle? R. Angle of reflection. So what we say? Angle I is equal to angle R. That is the first law. That angle of incidence is equal to angle of reflection. I just tried to show you how it is made. So that is the first law. Second law, the incident ray, the reflected ray, and the normal all lie in the same plane. Agree?
Yes.
That's all. So we know you have understood everything. Any problem so far, better?
No.
This is exactly whatever we did for the light. Start reading. Start reading. Ismail.
Okay. Take two pipes of the same length and arrange them on a table near a wall or metal plate. Keep a clock near the open end of one pipe and try to hear sound of the clock through the pipe by
No,
adjusting
other pipe.
the of pipe
Better don't delete any word. Through the other pipe.
through the other pipe by adjusting the position of the pipe. Now measure the angle of incidence and reflection. Then leave the second pipe and try to hear the sound. It will be it will be
Hmm.
seen that the angle of incidence is equal to the angle of reflection. The incident ray, the reflected ray, and the normal all lie in the same plane.
Okay, thank you, Beta. Now we'll do the activity straight away, okay? What is this activity is trying to convey?
That the
That we
incident
take
ray,
a,
reflected ray,
yes, yes,
normal
yes.
all lie in the same plane.
Okay, fine, good. First, we will do the activity. This is a metal plate we have taken, okay, Beta? And this is one pipe, okay? This is one pipe we have taken. And we have kept a bell or alarm clock. It's up to you. You can do this activity at home also. You understand? So either you
Yes.
put a table clock, alarm clock, and adjust in such a way, and then you have to adjust this pipe, the second pipe, this pipe. You have to put your ear, adjust the pipe, that whether you are able to hear the chimes or the ringing of the bell. You understand now? So you have to adjust the pipe. After adjusting the pipe, what you see, if you measure this angle and this angle, this is I and this is R. So what you will find? Angle I is equal to angle R. This is what you will observe. You understand now? Moreover, this incident ray, this reflected ray, and this normal all lie in the same plane. You agree?
Yes.
Yes? Okay. Now, one more thing I want to tell you. If I put this pipe over here, for example, I'm saying better. If I'm putting this pipe over here and the bell also over here, okay, where will be the second pipe better? It will be near the normal or away the normal? This pipe I'm talking about. Where I will keep it? Towards the normal or away from the normal? Tell me.
Towards the normal.
Exactly, exactly. It should be towards the normal. The pipe will be over here. You understand, all of you?
Yes.
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 And if I put a pipe over here, away, can you see this over here? If I'm putting a pipe over here, where the other pipe will be better? It will be here. You understand now, all of you?
Yes.
All of you understood? Showing that angle I is equal to angle R. So this law follows everywhere. Is it clear to all of you? Ninth
Yes.
standard. Saheem?
Yes, ma'am.
Yeah. I'm not getting any yes or no's. Are
No, ma'am.
you understanding?
Yes, ma'am. Yes, ma'am.
Okay, fine. Abrar, Abrar, are
Yes,
you
ma'am.
there? Okay.
Yes.
Will you be able to explain to me, beta, this activity? What are the two laws from this activity? What are the two laws, beta? What are the two laws of sound? The first law is what? Which one, beta? Don't disappoint me, beta. Please. What is the first law of sound from this activity? Hello. Okay, Smile. Tell me what is the first law?
Of which
This one, beta. The one activity which we are doing.
the incident ray, the reflected ray, and normal all lie in the same plane.
Okay, this is the second law. What is the first law?
First, the angle of incidence is equal to angle the normal
No, no, is equal to the angle of reflection, beta. See, this
is
is what I
equal to angle of reflection.
reflection. Exactly. So angle I is equal to angle R.
R.
This is it. This is it. Okay? You understood now, beta?
Yes, ma'am.
The ray is going here and the ray is coming out. Got it?
Yes.
So, Abrar, did you understand, beta? Hello? Did you understand now? Is he there or not? It's the same thing, reflection of sound. Got it? Just I want to let you know what it is, just the activity what we did just now. So this is incident ray. You agree, beta? All of you agree? This is incident ray and it is coming out and you are hearing it. So this is reflected ray. You agree?
Yes,
And the screen that you observed, the blue one, this is normal. Am I right?
yes,
Yes, this is what we got. Now, if you find, if we just measure this angle and on that side we measure that angle, we'll find this is I and this is R. Both are equal and this incident ray, normal and the reflected ray all lie in the same plane. See, this is the same plane, beta, right? They all lie in the same plane. So I hope the things are very clear. So what observation is we observed here? What observation we had over here? That similar to light, sound also obeys the same law of reflection. So light and sound obey the same law of reflection. Because in light also I showed you that this is what has been followed, remember? And in sound also we did the same. Now we come to a new observation regarding sound and that is called as echo. What it is? Echo. I think you are well versed with echo word, what it is exactly. That if you clap or if you shout, your voice can be heard in series. It comes to you, it comes back to you in series, one after the other, and later it gets faint. That is called echo. Is it understandable, better?
yes.
Yes.
Okay, please read.
Echo. If we shout or clap near a reflecting surface, like tall building or a mountain, we hear the same sound again. This sound which we hear is called echo. It is called it is caused due to the reflection of sound. To hear an echo clearly, the time interval between the original sound and the echo must be at least 0.7 seconds. Since
No,
the
it is
speed
1. It is
0.1
0.1 second. So to
0.
hear it, 1 second.
Yes, 0.1 second. Since the speed of sound in the air is 344 ms.
Beta, this meter per second, how many times I should say beta?
Meter,
If I'm,
meter per
if
second.
just a moment, it's mine. If I'm correcting someone, that means I'm correcting the whole class. Isn't it beta?
Okay.
So be careful. The distance traveled
The distance traveled by sound in
in
0.1 second, 344 meter second multiply 0.1 second is equal to 304 4.34.4 meter.
okay. So what is the distance? Distance will be 34.4 meter. Fine. Then
So to hear so to hear an echo clearly, the minimum distance of the reflecting surface should be half this distance, that is 17.2 meter.
okay, fine. So what did you understand by the way? What is echo? You read it. You read echo. What is the summary?
Echo means if we echo
In
means
your
if
own words, what you understood from you read it out, isn't it, beta? So what you understood out of that? Give
yeah,
me your version.
okay. Echo means that if we speak anything, our voice is reflects and come to us.
Exactly. Very good. So that is echo. Fine. What else? Anything else you want to add? Is the echo, is the sound comes to you very clearly or it comes as faint?
First time it's come clearly, second time it will
Fade.
faint,
Isn't
third.
it? Third time the sound becomes faint as the time passes by. Is it clear?
Yes.
Okay. That means the first sound that you get, what should be the difference of the timing? To get the echo clearly, what should be the difference? 0.1 second.
Hmm.
To hear your echo clearly, what should be the time difference, beta?
One
0.1
sec.
second. This is what is required to hear the echo clearly. You should remember this time. Okay. And to hear an echo clearly, the distance, now we know the time. What should the minimum distance to hear the echo clearly? 17.2 meter. Now, hope you have understood all of you.
Yes.
So, time should be 0.1 second and the distance should be 17.2 meter to hear the echo clearly. Is it clear to the whole class, Peter? Any problem? Peter, any problem?
No.
No.
No? Okay. Now, where do you get echo? Generally, we get echo like tall building, mountain, or ruins, the monuments, what we call as khandher, ruins of palaces. Hope you understand?
Yes.
Which has got huge domes, no one is using it. So if you shout, that sound gets reflected back to you and it comes to you in series. Sometimes it is haunting. So that sound that is getting reflected and comes back to you, that is called echo. You cannot see or you cannot hear the echo in your classroom, at homes, can you? On roads? You
No.
don't. You hear the echo only at certain places better, where your voice gets reflected. Now, what is this? This is reflection of sound. And we already know that to hear the echo clearly, the time interval, the time, what do you call this, lapse between the original sound, that the sound that you gave, and the echo that is coming back to you should be minimum 0.1 second. Should be at least 0.1 second. That should be time lapse between the sound that you created and the sound that is reflected back to you as an echo should be 0.1 second. Okay? And the minimum distance when the sound will get reflected should be 17.2 meter. You understand?
Yes.
Okay. What is the second one? It is reverberation. Yes, please read it better.
Reverberation echoes may be heard more than once due to repeated or multiple reflection of sound from several reflecting surface. This causes presidency of sound called
Persistence, please read properly. It is persistence. And don't rush. This causes persistence of sound called reverberation. You understood better?
yes. This
Yes,
causes
read it again.
resistance of sound called reverber
Reverberation.
rever,
Reverberation.
reverber
Reverberation.
reverberation in big halls or auditoriums to reduce reverberation. The roofs and walls are covered by sound absorbing material like composed
Fiber.
fiber boards,
Fiber.
fiber boards,
Compressed fiber boards,
draperies,
rough plaster
or draperies,
is draperies. What it is better? It is
draperies.
draperies. Thank you. Now we are talking about reverberation. What is reverberation? Many echoes from all over. Now you got the difference between echoes and reverberation, beta?
Yeah.
Echoes is one reflection coming back again and again. And reverberation is many reflection, repeated reflection, multiple reflection from all over the surfaces. And the sound remains in that either it is hall or it is auditorium. So it won't be clear to us whenever we hear someone speaking in the auditorium or in the hall. So what is done? The roofs and the walls they are painted or they are covered by certain sound absorbing materials. For example, compressed fiber boards, rough plaster, or draperies. The draperies are the huge curtains you must have seen. It's a huge curtains, the wall curtains. Those curtains are called as draperies, जिसको आप पर्दा कहते हैं. You understood?
Yes.
Huge curtains. Okay, so they are of certain materials that they absorb sound. You
Ma'am, time
understand?
up.
Yeah. Thank you, ma'am. Thank you for letting me know about it. Okay, any problems so far, beta?
No.